It's streaming, it's streaming, it's streaming. Okay, what about Enki? Let's see if this, okay, sick, this works. Alright, so what is the percentage volatility of the geometric Brownian motion process? This is the standard deviation of the value of the geometric Brownian motion process at, say, some time delta t, minus the value of the geometric Brownian motion process at some time t over the initial value at time t. And that's actually equal to e raised to the u times delta t times e raised to the sigma squared times delta t square roots minus 1. Okay. Square root of e to the sigma squared times delta t. What is the instantaneous variance sigma squared of a Brownian motion process in the context of modeling stock prices? So I think the instantaneous variance sigma squared should be the volatility squared, right? The squared volatility of the actual standard deviation of returns for the stock itself. But I can double check on that.
You got one more day of studying. Lock in here.
Lock in, lock in. Skip this one for now. What is the minimum tick size for price quotes in the SPY ETF? I believe it's going to be 0.0001 $. So maybe a hundredth of a cent. Yeah, 100th of a cent. Jensen's inequality is a way to express the relationship between the expected value of a convex function and the value of a convex function whose input is the expected value of x. And those two are, the relationship is the expected value of the convex function is greater than or equal to the expected value of x that's inputted into the convex function. What is an intuitive proof for Jensen's inequality? So I think if you have some type of curve, let's say a parabola, and you draw a straight line that connects 2 points, maybe not a straight line, but a diagonal line, and you'll see that the expected value of a convex function is the midpoint of the diagonal line, but the expected value of x that's input into the convex function is at a point that's lower than the actual midpoint of the diagonal line. Right, okay, so this is the expected value of x on g of x. This is expectation of g of x. This is the value of a geometric Brownian motion process, the output of a convex function. It should be, because geometric Brownian process is just e raised to the power of a Brownian motion process. what does P of t plus delta t represent in the context of geometric Brownian motion? So I believe this is just in increments in the geometric Brownian motion process, and the increment itself is, if you take the log of this, then it'll be the log, or the Brownian motion increment. Exponential increment of Brownian motion process. You have discount factors that correspond to different types of compounding frequencies. Yeah, we can. Continuous compounding, discrete compounding, simple interest, or discount rates. How is the perpetuity formula related to the golden growth formula? Perpetuity formula is just a special case of the golden growth formula, in the sense that our g is 0, so we get a constant dividend with no growth, and then there is no risk premium involved in the actual asset itself, so it's a risk-free asset. Okay. How can we express the price of a zero coupon bond that has been continuously compounded at a rate of R? The price of a zero coupon bond. So a zero coupon bond is a bond that doesn't pay out any interest at all, and is issued at a discount, and matures at the par value at maturity. Okay, so maybe expressing the price of a zero coupon bond, we could take the future value, the par value, and then divide that by 1 plus e to raised to the r times m, where m isn't the time period until maturity. I guess r is our annual continuously compounded rates. So we divide that, and that should give us the present value, or the price of a zero coupon bond. Okay. Number of compounding periods, just what is the expectation of P of t plus delta t P of t? If P of t are the value of the geometric Brownian motion process. So I think the expectation of the increments in the geometric Brownian motion process is the underlying mu of the Brownian motion process minus 1/2 sigma squared. 1/2. Okay. E to the u times delta t plus 1/2 sigma squared times delta t. So the expectation depends on delta t. Okay. If we are working with continuous compounding rates from a model, how can we express the value of the zero coupon bond today given the value of the zero coupon bond at maturity? So if we're working with continuously compounding rates from a model, if we're given the value of the zero coupon bond at maturity, so that should be the principal amount, then we can just divide the maturity of the principal by e raised to 1. Alright, maybe not even 1. It's just e raised to the e raised to, we'll call our model R, so we input t0 and then also the m, so it gave us an interest rate, and then we multiply by m. Okay, so this is what I've said. What is the research paper that Myron Gordon and Eli Shapiro wrote on the dividend discount metal call? Okay, so I think this is capital asset pricing, capital equipment pricing, something along capital equipment analysis, the required rate of profit. Okay, this is unnecessary for my exam, so I'm going to just skip this for now. Given yield curve or model of yields for a zero coupon fixed income compounded continuously takes in the maturity M, how do we find the value of the bond at maturity? So we can find the value of the bond at maturity if we're given the price today and we multiply by the actual, I guess you can call it compounding interest, continuously compounded interest that we receive. And so I guess we'll call it the gross continuously compounding interest. So that would be E raised to the R, and then we input into our yield curve or term structure the time t0 and also the maturity M, and then we multiply that by M. Okay. Is P of t plus delta t over convex function of P of t? Okay, yeah, so we had just described that this is a convex function because we're exponentiating the increment itself. Oh, P of t. Okay, so P of t is equal to e to the t plus delta t, and then we divide it by. Okay. We can calculate Jensen's alpha by taking the required or the expected return on an asset, we subtract the risk-free rate, and then we subtract beta times the market risk premium. That should be whatever is left over.
Can I show you a video for like 2 minutes?
Nah.
Really cool video.
Nah.
Has a dog in it.
Nah.
It's a dog driving a car, like unironically.
Show me later. Show me later.
You ever watch The Social Network?
Yeah, yeah.
Are you wired in right now?
I'm wired in.
You wired
Give
in? I
me
gotta
a-
be like, fucking, was it Andrew Garfield? Oh, he's wired in? He went just like takes the computer. How about now? He's still wired in.
Is that the end? Or no? Is that?
Well, it's at the end when you get fucked, right? When you screw up the
right.
company. I just do that. Are you still wired in?
Given that P of t0 is equal to the Gordon growth model, okay, so what happens when G is greater than or equal to R and when G is less than R? So when G is greater than or equal to R, then this actual model itself breaks because our sum never converges, and so it just goes towards infinity. Now when G is less than R, then our sum does converge because the numerator is below the denominator, and some really smart mathematicians prove that it converges to d of 1 over R minus G. My nose is itchy. Okay. What is the percentage volatility of the geometric Brownian motion process? It should be equal to e raised to the u times square root of e raised to the 1 to the sigma squared times delta t. Let me subtract 1. So it'll be e raised to the u times delta t plus square roots of, oh no, because it's the square root of the entire thing. Right. So expectation if P of t and P of t was value of the geometric Brownian motion process. So the expectation of the increment is going to be e raised to the u times delta t minus 1/2 sigma squared delta t plus 1/2, or is that minus 1/2? Okay, so it is plus 1/2. Right, because, okay, I see why. Because this expectation is greater than or equal to this expectation by the Jensen's hypothesis, Jensen's inequality. Okay. Notes by Jensen's. What does Jensen's tell us about the mean? Call it the mean of geometric Brownian motion process versus a regular Brownian motion process. What is by Jensen's equality? So we have the expectation is greater than or equal to the expectation of, we'll call this P of t plus delta t, so that's one value of our Brownian motion minus P of t. Right. Because the expectation, okay, because e to the x is a convex function. Therefore, we need an adjustment term which looks like the following. It's just u times delta t. Well, we have to add this 1/2 sigma squared to the expectation of our geometric Brownian motion process. What is instantaneous variance? Instantaneous variance. Instantaneous. Okay, so I guess instantaneous variance is the squared volatility of some type of stock price. Squared. Okay. Formula for covariance. So covariance is a measure of how much, say, one asset moves in respect to another. That's a very basic way of saying that, and I'm sure there's a more concrete definition. I remember one in Stack Exchange was talking about something about rectangles. Don't fully remember, but I think for the formula for covariance, we can take the sum of the product of the differences between, let's say we have two random variables x and y, so it'll be a value of x minus the mean of x times the value of y minus the mean of y for all of the possible values of x and y. And then we just divide that by, I believe, n minus 1 for unbiased covariance for sample, sample covariance. Expectation of Ri minus Ui. Fun Ui. For J, expected value, population mean of Rj. What is a financial instrument used to lock in the price of the S&P 500 in the future? I believe this is the E-mini contract. CME E-mini. Yeah, still don't know how it's traded. What is a vertically simple plane region R? What the hell? Why is this in R? Okay, so I think for a vertically simple plane, this is something I was trying to learn for Calc 3. That exam already happened, which I did okay on. I'll see what happens. But a vertically simple region plane, I think, should be a plane in which, if you look at it, if you kind of cut vertical pieces of this plane, then you should only have. Okay, let's say this: if you draw a vertical line through the plane at any point or any region, then the line should only intersect the outer boundary of the region twice. I think that's what vertically simple means. There are two continuous functions, g1 on the interval such that g1 is. And see that there are two functions that determine top half and bottom half of the range. Two continuous functions, g1 and g2 on the interval ab such that g1 is less than or equal to. Okay, so I guess there's two functions that make the top and bottom. Okay, I'm just gonna bury this a little bit, put it easy. So is p of t plus delta t a convex function of p of t plus delta t minus p of t? Yeah, so we established that p of t plus delta t over p of t is just the increment of a geometric Brownian motion process, and a geometric Brownian motion process is convex because we're exponentiating a, I guess we could say, a normally distributed, maybe a linear underlying variable. Sharp ratio of 1 implies that for every 1% increase in, let's say, our risk or our standard deviation of risk, standard deviation of returns, then we also get an extra 1% increase in excess returns. Okay. Term structure of interest rates is just another way of saying the yield curve, which is just a function of the time today and the maturity in the future, and will spit out some type of interest rate that you would receive on holding an investment starting from today until M. 0. Yeah. Okay. How can we interpret the Sharpe ratio equation? Describe the intuition. So the Sharpe ratio is just a risk-adjusted measure of returns, and we can calculate it by taking the expectation of our returns minus the risk-free rate. And we divide it by the standard deviation of returns, which is a way to think about risk. And so I guess what this means intuitively is how much are you earning in excess of the risk-free rate while also normalizing for the actual volatility of your returns, which is another way of risk. So how much are you earning in excess of the risk-free rate while also considering how much risk you're taking on? For every 1% increase in standard deviation from the mean return of the investment, normalize the returns from risk. What is the main difference with the units of the increments of a geometric Brownian motion process versus a Brownian motion process? Ooh. So maybe the Brownian motion process is log price or log returns, and the geometric Brownian motion process is percent returns. Difference. Ratio of asset prices over time. So it's change in price of an asset as a ratio of asset prices over time. Okay. Did not really get that, so I'm going to put that as hard. What is the relationship between the equal weighted returns and value weighted returns over the past 100 years? What is the intuition behind the relationship? So for the past 100 years, I graphed this out in one of the first problems, our first homework problems that we ever had. And we saw that the equal weighted returns and value weighted returns, they had some pretty consistent fluctuations for the first, let's say, 50 years from the Great Depression. So from 1922 to 1970s. But after the 1970s, for a period of about 40 years, the actual equal weighted return index performed a lot better than the value weighted return index, which suggests that equal weighted returns are weighted by price, not by market cap. And so in that index, small cap companies have a higher weight compared to value weighted companies, where the actual weight itself comes from the market cap of the company. And so if the equal weighted returns perform better than the value weighted, that means at some point some small cap companies outgrew the the bigger cap companies in price. And so that suggests that this relationship between the two. Okay. Since 2005. Okay. Different compounding frequencies affect the interest rates, the term structure of interest rates. Yeah, they do. So you have different yield curves for different type of compounding frequencies. Okay. Covariance of the return of two assets. So let's take the sum of let's say the return of an asset at any time minus the mean of that asset times y minus the mean of y, and then we divide by n minus 1. So the total number of assets we're comparing. Returns for a single asset will affect the returns of another asset. Okay. Because the covariance measures how much of the returns for a single asset will affect the returns of another asset. What does Jensen's inequality tell us about the mean of a geometric Brownian motion process versus a regular Brownian motion process? So the Jensen's inequality suggests that the expectation of a convex function is greater than or equal to the expectation of x input into the convex function. And so what this means in the context of the mean of a geometric Brownian motion process versus a regular Brownian motion process, it's that the expectation of our geometric Brownian motion process is greater than or equal to the e raised to the expectation of the Brownian motion process. And so if that's the case, what is the actual expectation of our geometric Brownian motion process? So we learned in class that it's actually just e raised to the u plus 1/2 sigma squared, and we multiply by delta t. Horizontally simple region, same thing as before, but we do kind of like this horizontal line. Okay. Instead of having a 0 coupon bond being valued at P0, what is the initial price of the bond? Assume we're trying to value the bond after time delta t has passed. How would we determine the value PM at maturity using the value at PT delta t? So if we have a term structure or a yield curve, and we want to value the bond at, let's say, delta t after delta t has passed. So we can get the price of our, okay, so let's assume we also have the price at delta t, so p delta t, then we'll okay, so I guess it's not telling us to use continuously compounded rates or discrete compounded rates. I think maybe an interesting way to do this is with discrete compounding. We could do one plus the interest rates we receive from our model at delta t from m minus delta t, so that's how much is left. And then we divide by, call it m, the number of compounding is left over. And then we compound that by m minus delta t. Or I guess it'll be easier with continuously compounded rates. We could just multiply p delta t times e raised to the raised to the interest rate times m minus delta t. What is the main difference with the units of increments from geometric Brownian motion process versus a Brownian motion process? So for a Brownian motion process, we're finding the difference. So we take p of t plus delta t minus p of t. In the geometric Brownian motion process, we're finding a ratio, so it's p of t plus delta t over p of t. Asset prices is a difference of asset prices, as a ratio of asset prices over time. Okay, that's an important point actually. If dn is an annualized dividend, what is the actual dividend actually paid out of payment n? So if dn is an annualized dividend, we just have to multiply by, or I guess we could multiply by 1 over, maybe we can multiply by delta t, or where delta t is the time period in years in which we receive our actual payment. I think maybe we can divide dn by the number of times the dividend is paid out a year or two. Okay. Between time interval is the interval between each cash flow payment. Okay. So the discount rate, I think, applies a linear discount on the future value of our investment to get to the present value. And so the discount rate itself is, you could think about v1 times 1 minus R so we could take V0 divided by V1 minus 1 times negative 1. So it'll be 1 minus V0 over V1. Okay. How do we calculate the annual fee of a hedge fund? I think just the performance fee plus maybe a hurdle rates, incentive rates. This isn't tested, so I'm just going to skip this for now. Annual fee. Okay. Geometric Brownian motion. As the number of periods n becomes really large, what are the underlying forces affecting the expected value? Okay, so in our notebook we saw that as the number of period m becomes really large, then the variance becomes really large because the variance depends on delta t. And so with the actual expected value itself, as the number of periods become really large, only a small proportion of sample paths actually contribute to, let's say, 90% of the expected value. And in this case, if we had, I believe, 10,000 recorded dates using some type of parameters, we saw that the actual proportion, 10% of the sample paths or the sample returns actually contributed to more than 95% of the returns itself. Really well. How do we find the value? That one is hard. How do we find the future value of a bond that continuously compounds for k years given the price today? So the future value is equal to the present value times e raised to the r times k. How can you prove this? Yeah, I guess maybe we need some real analysis here to show that this converges to e as n goes to infinity. Okay. I think Euler had some sort of experiment, right? Where he did try to okay. What is a debtor? Person who owes money. Person who's borrowing money, okay. How do we replace NaN values with 0? Just do pd.fill NA and put 0. Oh, df.fill NA, okay. Rule 72 is a way to kind of approximate the amount of time it takes to double your money. And the way we do it is by taking 72 and then we divide it by the annual interest rates that you get from your return. Or maybe the annual return that you get from your asset. Investment 72, okay. What is a general rule when two variables have different units? You can multiply or divide them, but you can't subtract or add them. The relationship between the annual simple interest rates and these four variables, principal plus interest earned, number of times interest is paid out in a year n, and the investment period m, we can show that the principal plus interest earned is equal to the principal times 1 plus r times m. And we can divide r by n and also multiply m by n. And so the number of times interest paid out in a year kind of cancels out. Right. Paid out in a year. Okay. Given the following, yt is equal to earnings per share at time t, b is equal to percentage of earnings kept within the company, What is the dividend at time t? What is the intuition? What are the units of d? So you have an earnings per share at time t. So how much money a company has earned per share, per outstanding share, I guess, of stock that they have at time t. Then the dividend at time t should be 1 minus the percentage of earnings kept within the company times the earnings per share. So that will give you the dividends per share. The intuition is that whatever money or percent of earnings you're not keeping within the company, you're going to pay out to investors. And so that's 1 minus b. And then to get that amount that's actually paid out to investors on a per share basis, we just multiply the amount of earnings that are given out to investors by the total earnings per share. And so the units of D then should be dollars per share. Okay. I think I might tap out right now. I'm really hungry. So I think Brownian motion process is a difference in asset prices over time, and geometric Brownian motion process is ratio of asset prices over time. Yeah, I'm really hungry. Jeez. Okay. Nice. Alright, I think I'm going to stop the stream here. I am very, very hungry. I need to go. I need to go shower, go shave, and go eat. So I will see you guys later.